This session is going to be dedicated to discuss the interfacing circuits as a part of the input-output organization comes under the module 2. So let we see that presentation milestones. Interfacing circuit going to be discussed at the beginning, followed by the parallel ports, which is going to be transmit the data from the device to the device or processor. Combined I/O port will be going to be discussed. The serial port will be there, and this interfacing circuit for the appropriate standard I/O. The standardized this I/Os the contains, that is the interfacing circuits will be followed. That is an I/O interface consists of the circuitry required to connect I/O devices to computer bus. Side of the interface which connects to the computer has the bus signal for address data control. Interface which connect to the I/O devices, the data path. So data path, you can say that the complete hardware which will be put it in the on the motherboard, that could be a processor, buses and I/O devices, network interface card, and the monitor, and all those related hardware will be kept on the motherboard. The entire hardware we can call it as a data path, which associates to control to transfer the data between the interface and the I/O devices. So this is connect to the I/O device, and this side is called as a port. Port, you know that it will connect to the real world, to the digital world. So any device which may be keyboard, it is a real world. From the real world input want to enter into the processor, through the port only they can enter. Similarly, the other concept, uh, the other one, that is the parallel port. This kind of port will be parallel port or serial port. So the parallel port it will be take the byte or word at a time, whereas serial port will be take bit by bit. So this kind of mechanism going to be exercised in the concept, that is. So here interfacing circuit will be there, and parallel to port transfer the data in the form of number of bits, normally 8 or 16. Sometimes latest machines will be follow the what we call 32 bit also to or from the device. Serial port transfers and receives the data on the bit at a time. So that is a bitwise transmission. So processor communicate with the bus in the same way, whether it is a parallel port or serial pattern port, no matter, it will be normally communicate. So even it may not come to the notice of the user. So even serial port, it will be with help of the shift register, the all the 8 beta. If you are handling 8 bit machine dedicated for 8 bit, all 8 bit beta should arrive and keep in the register. That will be sent once per all. And it will keep wait for all the 8 bit or 16 bit arrive to that buffer, whereas in the parallel port will be it will be sent byte word at a time, that is. So that is a mechanism will be there. So we can have that conversion from parallel to serial and vice versa. It takes place inside the interface circuit. So there is a interface circuit will be there inside this one, that we call data path. So and all this CPU the blocks that will be cater the needs of this interface circuit, that will be forward. So we have parallel port, that is a parallel port, there is a processor will be there, and we have a what is called interface circuit will be there. So interface circuit constrains the registers, one register called data in, and the 1 bit flag, that is a SIN. So this flag will be tell us about the data is arrived or data is ready, or this keyboard is ready to receive, and so on. That based on the status of this flag will be decide, that is. And the processor will send an address. Interface circuit bring some data from the keyboard or the other devices, so it will send some address. Then once this the interfacing circuit receive that address, it correspond communicate to the corresponding device which may be connected to the memory or IO devices various, and once it is identified, it will bring back the data to this processor. So thus mechanism will be happening. So once the address placed by processor and data got from that other devices, whether we need to be write or read, so that signal will be sent by the processor. So that is happen. So master ready means that processor is a master right now, it will be initiate the operation to for future operation. The processor is now ready, the other side slaves is ready, like that it will be asked to the devices. So once the slaves, maybe keyboard, maybe printer, maybe scanner, if it is ready, then slave will be response come to the processor. So processor will be start the further communication. So for example, for parallel board, that we can see that keyboard connected to switches to the encoder and debouncing circuit. So the debouncing circuit will be, the data will be sent to this data in register. So validity will be there, valid bit will be check if the key bounce, that is a bouncing circuit will be provide and reply the proper key has pressed by the user, so that that key is valid. So no doubt in that, there is no oscillation and all those, so that validity will go to the interfacing circuit. So that is the key mechanism will be exercised here. Keyboard is connected to the processor using a parallel port, right? So parallel port, the all this characters will be go to that interfacing circuit after coding. Processor is a 32-bit and use memory mapped IO and the asynchronous bus protocol. There earlier it was 16-bit, now 32-bit is also there. So on the processor side of the interface have the data lines and address lines and control or read write lines will be there, right? So this mechanism will be exercised, that is other signals called master ready signal, slave ready signals. So the master from the processor who is initiate the operation, slave from the slave side, that is clients or the devices, so or the target device. The master is the initiator, slave is a target one. So though both should be handshaked, the agreement there should be signed for the communication. So the parallel port continuation, there is a on the keyboard side interface, the encoder circuit will be there, generates the key, proper key has pressed by the user, that will be certified. Debouncing circuit, which eliminates the effect of the key bounce, so that sometime that bounce will be there, key will be not pressed properly, so that slow pressure and sometimes more. So this debouncing circuit will be look up to the threshold values and all those. It will take an average and tell the proper key will be has pressed. A single a key stroke may appear as a multiple events to be processor. The data lines contain the code for key. Valid line changes from 0 to 1 when the key is pressed. When the key is pressed, that 0 to 1 will be validity will go there. So that will reach to SIN flip-flop. This causes the code to be loaded into data in and SIN to be set to 1. This SIN will become 1 after the valid signal coming from this debouncing circuit. Along with the data will be occupied in the data in register. So this mechanism will be happen during the interface connection. So keyboard input interface circuit will be there. So there is a output lines of data, 8 lines are linked to data lines, thus bus busy by means of 3-state driver. Sometimes you can also call it as 3-state buffer. So this is a 3-state driver. So input is coming from this D flip-flop. So data enter as a keyboard to this flip-flop, and it will go to this tri-state driver. So data coming enter into this driver, so that is controlled by this input. If this input is high or 1, and input become output, otherwise no output will be generated. Similarly, all the tri-state driver will be happening. The complete data will be there at the D0 to D7. So driver are turned on when the processor is issuing a read signal, and the address is selected to the register, right? Register. So here we can see that, so valid, we can see that valid by the debouncing circuit will be produced. So that will be drive the this data in register, that is a D flip-flop, and same thing will go to the status flag. This status flag will go to the SIN, and the tri-state driver, there is a controlling input will coming from this side, that is a read status. So read status will make a work as a control valve for the SIN. If SIN input become output, only this is enabled, high state read status, otherwise it will be no output will be generated. So this status flag will be there, right? So another one is a read data and read status together decide the slave ready signal. So slave ready input is 1, but controlling valve will be decided by this read status and read one, that is right. So SIN is generated using the status flag circuit. The status flag circuit will be, as I said, it is a status flag from the valid. So valid, again, that is a valid will be a status flag is also getting generated from the master ready signal. And read write bar signal. So this master ready signal go to the status flag and valid, and all together will be decide the SIN. So and also there is read status will be coming, right? So read status and valid bit and SIN, this report to the status flag, all together decide the SIN will go there. So the next one is, it is connected to the line D0 of the processor bus using a 3-state driver, that is a D0 SIN connected to D0 using a 3-state driver. Address decoder select the input interface built on the bits A1 to A31. So the addresses are there, A1 to A31, used to select that register, that input device built onto the A1 to A3. So that will be identified, the address will be identify that device. So we have bit A0 determine whether the status or data register is to be read. So read status and read data, it will be decided by the bit A0. Bit A0 to be read when memory master ready is active. When the master ready is active, that A0 will be take that is also will together will decide, that is. So in response, the processor activates the what is called slave ready signal. In response, slave ready signal activates the slave ready signal. So altogether this A0 and this master ready read write bar altogether will decide the read status and read data. Then combinedly this will goes to decide the slave ready signal, that is a slave ready signal. So when the either read status or read data is equal to 1, which depends on the A0 obviously. So the in response, the processor activates the slave ready signal when the read status and read data is equal to 1 only. Then the read signal, what is the slave ready signal will be decides, that is again that depends upon the A0. That is A0 is a part of the address. 31 bits are there, 1 bit will be given to that status, and remaining address will be used for that is. Similarly, keyboard, now you can think about the printer. So if you connect the printer, what will happen? So printer will be there. So the printer is connected to the processor using the parallel port. So similarly, we can have data address will be there, go to that is. There we were discussed data in, now data out. There we discuss SIN, now S out. This is output interface. So output interface will receive the data from the address from the processor, and also data. The address will be tell and data will be there. In this address you need to write this data, whether read or write. So we have to write master ready signal will be there. Then corresponding slave ready will be expected from the processor. So that is a handshaking or agreement between the sender and receiver. To in order to have a communication, you should agree for communication, right? So like that, master ready slave ready signal will be reciprocate. So once the data has sent by the processor, whether read or write, it go to the printer. So the printer will be print, that is, along with that validity bit will be there. So idle will be there means the printer is ready, it will send a signal. So I am ready, you send a data. So like that it will be obliged and it will be print the information. So now the processor is 32 bits, use memory mapped IO and asynchronous bus protocol. So there is a different lines are there. The buses, data address control, right? Control may be read write signal or IO control or IO read and or configure the IOs or provide the address for the different devices. So all those is the controlling the signals will be go to the control signals bus, control bus. So there is a additional signal as we see in that master ready signal, slave ready signal will be there. So having understood this, so printer will be there, printer side idle signal which will be printer declare, it proclaim that so I am ready, printer said. When it is ready accepted by a character, so it is ready to print. This causes a S out flag to be set to 1. So when the printer said it is ready, then S out signal will be set. That is one bit flip flop set to 1. And processor place the new character into data out register. So when the printer said it is ready, then processor immediately send the data to data out register to print. So valid signal declared assisted by the interface circuit. When it place the new character on the data lines, it will going to be print. So the output interface circuit will be there. So we have individually seen in the previous slides, that is a keyboard interface and printer interface. In the keyboard, that is a input interface case. In the printer, it is a output interface circuit. So now you can see in length in a full-fledged manner how this interface circuits will be, especially output will be there. So data lines of this processor bus are connected to data out register of the interface. So there is a the D0 to D7 is the data lines. It is coming to D flip flop connected here. So that Q0 to Q7 is the output. So that is go to the printer. So that is a parallel port. So status flag S out is connected to the data lines, that is D1 using 3-state driver. So D1 will be make use of a 3-state driver. So that is a S out will be connected. Again that is a handshaking signal, valid bit, idle bit will be input. So the handshaking signal will be S out will be sent. So that is connected to D1. So that is a D1 is a 3-state buffer. And here as we discussed in the previous slide, that read status and load data, that is going to be decide the slave ready signal controls. So in the previous that we have seen that A0 has played a role to decide read status and load ready and master ready signal. So the 3-state driver is turned on when the control read status is 1. Control read status is there, no? When it will become 1, 3-state driver will be produce an output, that is a slave ready signal. So address decoder selects the output interface using the address lines A1 to A31. So A1 to A31 address lines will be there. So this is going to be a decode along with the A0 we have discussed in the previous. So that will be decide the load data and read status. So together master ready signal, read and write bar all together will be going to be decide the read status and load data that we discussed in the previous slide. More or less it is same to that. So address line A0 determines whether the data is loaded into the data out register state or status flag is to be read. If the load data is line is 1, then the valid line is set to 1. So valid data will be set to 1. So that will be how come, that is a low data, that will decide the valid data, that valid line, valid line. So if the idle line is 1, then the status flag is S out to be 1. So 1. So that is the status also decided by this idle line. So idle line will be coming from the that printer. So printer is free if it not printing job, or if it is not busy, if it is no jobs are queue to print, to be print. So in that case, if no such the assignment, then it will say idle. So this idle also decides the S out, right? S out signal. S out signal, that is 1 bit flip-flop in your what is called output circuit, right? Output circuit that we have discussed. That is. So the combined this input and output. So how it would looks. So that again, that A2 A31. So that is these number of 30 lines will be used to select the overall interfaces. So 2 power of 30, those number of interface circuits may be possible to connect to the system. So here A2 to A31. So these address lines are will be there. So decodes will there, and my address will be generated. So go to this AND gate, together this master ID signal, read and write bar signal, and all those will go there. So address lines bits, that is A1 to A0, that is 2 bits select one of 3 register. 2 bit can be identify the 4 registers. So one of the 3 registers, namely data in, data out, and status registers. So out of 3, any one register going to be identified. For that A0 and A1 address will be enough. A0 and A1 address will help us to identify the 3 registers. What are those? Data in from the what we discussed the as a input circuit, which represents the keyboard. Output circuit, which represents the example of the printer, right? There we need a data out. So status register will be required for both. So all these three you can uniquely identify at the given instant of time from the lines A0 and A1. What is the A0 to A31? So these are the total bundle of address will be sent by this processor to in order to communicate with the devices. So how we can identify those devices? There is a n number of devices are connected to the processor, right? So those n number here 2 power 30 number of devices can be identified from this, right? So 2 power 30, those number of devices possible to connect to the processors. With help of this address you can easily identify them. So A0 to A1 will be looking up to identify these registers, data in and data out, right? So this kind of mechanism will be going to be exercised when you are going to be achieve that augmented IO, or jointly producing the circuit for generality. So in order to avoid the repetitive components, so that status register contains the flags SIN and SIN bit card. That will be 0 to 1, 0 and 1. So SIN is 0 and S out is 1. SIN is 0 means that it acts as an input circuit, input interface. S out is 1, it acts as an output interface, right? So the data in, data out, and status register SIN and S out, so altogether this will be identified with the help of the address, that is A0 to A1, that is a LSB of the address, LSB, least significant bit of the address. So total 32 bit address will be there. A0 to A1 will be looking for to identify these registers. The higher lines will be dedicated to identify the device number, device ID. So data lines are connected to the port A, right? Port A, that is A0 to A7 is a port A, connected the input device to data in register. So port A will be there. So port A, the bits are A0 to A7 will be connected to data in register. So that will be go to the input status, and we have tri-state driver will be connected. So this will be go to D0 to D7. So data out register connect to the data lines on the processor bus to lines PB0 to PB7. So the data out will be there. That is a port B, port B, port B address from 0 to 7. This is connected to data out. So this data out which connected to the output device. This is output device. So this will be combined, this input and output circuits, with help of the hand signals, that is a CB1 and CB2, that is a control signals from this port B, right? So there is a control signals from port A. So this will be also go to the input status, and S out will be derived from this what is a handshake control signals, go to S out, and the read slave ready signal we have seen, that is decided by this A0 A1 and my address, master read and reader write bar. So altogether combinedly they will decide the slave ready signal. By default the slave ready input is 1, want to become output 1, then this would be high R1. So that is a tri-state driver will be drive the ready state signal. So the separate IO and separate input and output data lines for connection to a IO devices. So the data lines are separately for the input and output are there identified. So continuation of this. So there is a 8-bit data lines device have two data lines, port 0 to port 7 can be used as a input and output one, that is, if in fact some lines can be used for input, some for output depending on the pattern. So this can be decided by the contents of the DDR. What is a DDR? Data direction register. So data direction register, whether this data going to be output, then the data register contents will be decided. The data going to be input, that will be decided. So which direction data will go, whether go to from processor to outside or outside to the processor. So that will be direction will be decided by the contents of the DDR. So this there is a data in data out, right? So that will be combined, and the processor places 8-bit pattern into the DDR. So that is a DDR register will be there. So this data will be there in the DDR. If a given bit position in the DDR is 1, the agreed to data line act as an output. So data or DDR is 1, and this circuit will be only the it will be output, that is a output circuit will be active. This input circuit will be passive. It will be mute, otherwise it acts as an input line, right? So DDR1 says data out, that is output circuit. DDR0 says or converse, right? Converse, that is. So there is a register selection will be there. So what are the registers? That data in data out, SI in SI out flags will be RS1 and RS1 will be required for the register selection, that is data in, either data in or data out. Read write bar, ready signal, accept signal, and additionally there is a interrupts will be there. So in order to control this status and control, there is a condition codes called C1 and C2. So this will be decides the some interrupts mechanism will be exercised during the operations in order to stop the operations tentatively. Temporarily you want to stop, so there is a control signals will be generated. C1 and C2 controls the contact between the interface circuit and IO devices. Ready and accept lines are the handshake control signals. Control lines on the processor bus side and are connected to the master ready and slave ready, MR and SR, right? MR and SR. So input signal my address. So input signal my address is connected to an output of an address decoder. So my address will be connected to the output of the decoder. So the 3 register selects in allow up to 8 register to be selected. 3 register select lines, that is a 3 register select means we have R0, R1, R2. So 3 bits are there. 2 power 3, 8. So 8 registers you can identify. So here we can have notice so far data out, data in, S out, and the data register. So the fours are there. Like that, if any registers are going to be identified here or there, that these three address together will be enough. So that's why he is saying that is three register select lines that will be can able to identify uniquely up to 8 register, right? So the after discussing the parallel port, so we have a what is a mechanism of alternative, that is a say serial port that will be performed bitwise. Serial port used to connect the processor to IO device that require a transmission of data bit at a time. That means that bit serial fashion on the other side, and bit parallel fashion on the bus side. So bus will be talked in terms of the byte or word, whereas the other device connected to real world, that will be talked in terms of the bitwise. So this transformation between the parallel and serial format is achieved with the shift registers. So shift registers will help us to achieve this mechanism. Shift register is a register which contains the 8-bit information, for example, right? So the serially data occupied to this register, once that register is full, all the 8 bit data has arrived, and it will using the parallel port will send once per all, right? Once sent the 8 bit, then it will be similarly occupy the next 8 bit. So this occupation is bitwise and sending is bytewise. So that have a parallel access capability. This mechanism will be happening inside the that interfacing circuit will be without notice of the program or a user, which will be happening through the serial port. So here shift register accept the input bit 1 at a time from the IO device. So the serial input will be there. So this will be sent, that is, and once all the 8 bit are received, the contents of the input shift register loaded into the parallel into data in register. So that data will be there. So it will be occupy one by one, and it will be go once per at a one single stretch. It will go to data in register, that is connected to tri-state driver or straight test buffer. The output data in the data out register are loaded into output shift register. So output shift register bits are shifted out to output shift register and sent to the IO device one bit at a time, there. So there is a data out will be there. So from data into data out is a parallel fashion. Once the data out want to send to output device, so that will be output shift register will be there. So this will be sent once per all bytewise or wordwise from this register to real world or connected to next device, that will be going in a serial fashion. So that will be a serial fashion, serial port will be make use, that is. So the data will be connected. As soon as the data arrives, the input shift register are loaded into data in, it can start accepting another bits of data, right? So as soon as this data 8-bit data received, and they start receiving the next 8-bit data one by one, that receiving is bitwise and sending is a bytewise. So input shift register and data in register are both use input for the, so that input shift register can start receiving another set of 8-bit from the input device. After loading the contents to data in, before processor reads the contents of the data in, so this can called as a buffering, double buffering. What is that double buffering? After loading the contents to data in, before the processor reads to the contents of the data in. So this will be going to be happening in a parallel way. So the load and reading will be going in simultaneously. So there is a chip and register selection will be there. RS and RS0 and RS1 will be select the 2 power 8, that is 2 power 2, that is 4 the registers we can identify, that is data in data in, data out, and shift registers, read and ready signal, accept signal, will be there, and this is connected to what is called interrupt will be generated from the status control. So for that receiving clock and retransmission clock, that the condition codes will be there, go to that status control, will be decide that continuation of this serial port. So interface require a few wires. That wire is a collection of wire bus fewer wires, so that is act as a bus, and serial transmission convenient for connecting the most of the devices that are physically distant from the computer. So the which are very distant devices are there, that we can use the serial communication. Speed of the transmission of data over serial interface is known to be bit rate, right? So bit rate depends on the nature of the device connected. So nature of the device is most important. In order to accommodate a device with a range of speeds, a serial interface must be able to use a range of the clock speeds, right? So the serial interface must imply the range of clock speed is essential. Several standard serial interfaces have been developed. So maybe the RS-232 from IEEE, or UART, that is a universal asynchronous receiver transmitter for low speed serial devices. So this low speed we can achieve with help of this also, that is RS-232C for most of the internet connection communication links will be established. One such example called RS-232 standardized by the IEEE, right? So that is a computer, and this is a that is a master or transmitter. There is a modem which is a receiver or slaves. So in between these two have a wired connection through the RS-232 bus. So there is a connector this side towards the computer and other side towards the modem. Maybe here example of modem, in another case maybe a printer or maybe some keyboard or some various scanner. So the different input device, output device we can able to connect through the RS-232. So one side there is a pins are there. So this pin will be protective ground, transmission, receive, right? So we have that is a request to send. Request to send signal will be there. Go to the modem. Clear to send, and data set ready. Data set ready will be to from modem to. Then common return. Carrier detect, that detected the carrier. Data terminal ready. Data signal will be there. So this dialogue will be happening between this the master and the slave, or initiator or the target machine, or the computer and the modem, in this case through the RS-232 cable. So similarly we have one more low bit data in serial fashion, that is a universal asynchronous receiver transmitter. We have that the data bus will be there and control bus will be there. So these are will be in the parallel fashion. This will be mapped to the serial through that mechanism what we said discussed, that is a shift register. Shift register in and shift register out. So this receiver and transmitter. Similarly, this circuit you can see on the motherboard, which have the UART will be connected, that serial communication for the various device in the CPU. So that will be one mechanism. So interface that standard I/O interfaces will be there. I/O devices is connected to the PC using a interface circuit. So do we have a design different interface for every combination of an input device and computer? Practical approach is developed, standard interface and protocols. The personal computer has a motherboard which has housed the processor chip, DMA controller, then the interfacing circuits, then the memory chip, then I/O devices, or maybe interfacing circuits, or maybe some graphics card. So all those there will be in-house on the motherboard. So few connectors into which additional interface can be plugged. So some additional pen drive or some CD drive or maybe instantly we can plug into that. Slot is provided through the USB, so on that. Processor bus is defined by the signal on the processor chip. So device which require high speed connection to the processor or connected to directly to the this bus. So directly we can connect, that is. So standard interface will be continued, that there is a electrical regions also there for connection, right? So this motherboard usually provides the another bus that can be support more devices. So there is a main bus will have there, that is a system bus, and additionally that system bus will be high speed and their characteristics different, so they can sustainability is less for the electrical region and all. So furthest there is alternative bus will be going to be generated, so called expansion bus. The processor bus and other bus called an expansion bus are interconnected by the circuit called bridge. So bridge circuit will be there, is able to transfer the data with processor to the other devices via bridge, right? So bridge is a circuit, is a capability to transfer the data. Maybe processor talk in terms of high speed or for the less data, and the other side device will be more data and low speed. So this kind of there is a the gap of speed or size gap will be there. So that will be bridged through this bridge circuit. So the device connected to the expansion bus experience the small delay in a data transfer, because you know that these devices are electromechanical devices. The processor is a purely electronic device, so it's inherently faster speed, whereas the devices are slower, inherently they are slower. So there is a, that's why there is a some delay will be introduced. So some delay will be introduced between the this processor and the devices. So you know the heterogeneous this speed or heterogeneous size of going to be handled, multiple the differences will be there. Design of the processor bus is closely tied to the architecture of the processor. So this design of the bus will be evolved and the what we emerged, or we can also say that the imbibe or it may be influenced by the some of the architecture. Those architecture may be private or some R&D center. No uniform standard can be defined in that case. So there is expansion bus, however, can have uniform standard to be defined. So otherwise what will happen, the everybody they design their own bus, so that the plug and play may be quite difficult. A lot of commercial aspects will be involved, they might not get a huge business. So the commonality has to be informed arrive, that commonality will be only for standard one, not from the non uniform. So uniform standard should be there. So such the standards will be, the number of standards have been developed for the expansion of the bus. Some have evolved by default, so like open source. So some have evolved by some own their in order to solve their applications. Such application will be IBM industry. They have developed the industry standard architecture called ISC. So they have their own expansion bus the standards. So they have designed that, but it looks maybe non-uniform for the users. So the other the dominant expansion bus system will be the standards are the PCI, peripheral component interconnect, to connect the various IO devices to the processor. So one mechanism will be exercised by the PCI. The other one is the SCSI, small computer and system interface. The next one is a USB, universal serial bus. So these are very well known and popular. Most of the industry and most of the manufacturer of the system, they are beneficiary of this. So it is going to be huge usage of that. So in that line we can have processor and main memory connected to the processor bus. So processor bus is a high speed bus and less capacity the transmission of the data. So in order to connect to these devices, as we discussed in the previous slide, bridge is required. So bridge will be the data are heterogeneous. The speed will be different, matching non-matching speed. There is a PCI bus will be there. So this PCI bus is a bus suitable for expansion of the expansion bus kind of the additional memory. You want to memory chip plug in, so additional memory chip will be plugged into that. The SCSI controller is a SCSI bus. SCSI bus will be going to be communicate the small devices. We can connect in a daisy chain fashion. The last one will be terminator. So the Ethernet card or VGA card we can interface. So that USB controller we can put. So ISA interface, as we said, that IBM has developed their own architecture, that is a expansion bus. So the SCSI controller SCSI bus, this bus will be connected with the CD-RAM controller and CD-RAM, like that other CD-RAM we can connect. So there is a SCSI bus connected to the disk controller. Disk controller with the disk 1, disk 2 will be connected. So we have USB controller, there is a video port and various other device we can, keyboard, game player and IDE disk we can connect, that is. So the bridge circuit translates the signal which is and protocols from the processor bus to PCI, right? PCI. So it go to the processor to the PCI bus. Once it go to the PCI, then other controls will be there, they will make use. Expansion bus on the motherboard will be there. So this is a expanded bus on the motherboard. So this kind of mechanism we have discussed. I hope you followed, that is the concept from serial, parallel port and combined and the expansion bus. Thank you for patient listening. The topic interfacing circuit, which comprises the serial, parallel port and expansion bus. And the books are like this, the Carl Hemacher et al. And the title is Computer Organization, Tata McGraw publisher, William Stalling, Computer Organization Architecture by Pearson publisher. And apart from this, there is also books are there, you can refer. Thanks for coordinator and moderator, subject expert. So if you have any query, you can post the query to this mail ID related to this video lecture. Thank you once again.